First of all, thanks for being here. What I'm going to deal with tonight is science. I'm not going to depart from science. Verifiable, provable facts. I've got references, I've got quite a few references which I, if you like, I can produce. I'm going to try not to do too much because I want to keep it simple, but not too simple. As Einstein said, keep it simple, but not too simple. What I'm going to be talking about is basically that sine wave. That sine wave there, if it doesn't explain everything about the universe, well, it explains 99.9%. That's a big claim, but with a few graphs and a few pictures that I've put together, I should be able to prove that and give you some proofs. Alright, now, before I actually get into explaining what this can do, we need to cover some basic science, okay? First of all, some basics about how the solar system works, a little bit about physics, so we're going to discuss what's called the Platonic solids, okay? And with that, the elements, what they call the elements, fire, air, earth and water, and the fifth element, of course, being ether. I also want to talk about the universal fractal, and that's the Fibonacci ratio, and I feel very proud to have the name Bonacci, since it's the most universal fractal, or the most universal name. But it has to do with the golden section. It's called the golden section, or the golden mean, or the golden ratio. So we're going to have to study those, not too much, but just the basics of those three sciences before I go into explaining how this fella here is the most acrobatic little critter you'll ever see. It's a sine wave, but it's not two-dimensional, of course, it's a spiral. And without giving too much away, that is how everything in the universe manifests, which I will prove. Now, first of all, what we want to do is talk about the solar system. There are three fundamental motions in the solar system. Now, two of those motions we are all aware of. The first one is the 24-hour day. It gives us a polarity of day and night. So every 24 hours we get day and night. So little children become very, very consciously aware of that day and night process at a very, very young age. Then later on in life they become aware of the second cycle. That's the yearly cycle of 4 seasons. And every year, every time that we go around the sun, we add another year to our lives. So I've been around the sun 47 times, so I'm linked into the sun cycle. But it takes a while for little children to sort of get a conscious awareness of that. Now this is where I think society really, really falls over in respects of the solar system and science. And that's in the third fundamental motion of the solar system, which is what's known scientifically as precession of the equinoxes. Now, the precession of the equinoxes is also called the Platonic year because of Plato's work with the great cycle. And I'll put the figure on the board right now. That's the figure that the Western world has adopted. Comes from Egypt, comes from Babylon. All those guys have their monuments, like the pyramids and whatnot, to harmonics of this number. Now, in the East, they have a figure of 24,000. Okay, now, before I go any further, I'm going to say that I'm going to be using the 24,000 year model, okay? Now both of these figures are correct, but when the year is corrected, as I will explain in a moment, it reduces, it resolves to 24,000 years. Okay, so it's a 24,000 year cycle. You can argue it, but that's what I'm going to use. Bear in mind that I've seen in all the books that I've read about the precession of the equinoxes, and I've been studying this subject for about 30 years now, this cycle, that I've been aware of it for 30 years. I've only fully begun to understand it in the last 3 or 4 years now with what I've been putting together. But depending on when and where you calculate the motions of the cycle of precession, these figures are both correct. Now, I've seen varying figures between these two, usually not more than 25,920 and never less than 24,000. Okay? Now, I like this one because this figure, because this is a great book. Now, I'd like to read a passage from the opening words of this book. This is Sri Yukteswar. It was written in the year 1896. He's an Indian guru, a scientific man, and this book is just beautiful. It's called The Holy Science. Sri Yukteswar. His teacher was Babaji, and one of his pupils was Paramahansa Yogananda. So the reason I'm quoting from this book is I want to show that in the West we go with this number. In the East they tend to go with the 24,000. Now I'll just read a passage. It says, "We learn from Oriental astronomy that moons revolve around their planets, and planets turning on their axes revolve with their moons round the sun, and the sun with its planets and their moons takes some star for its dual," make note of that word, takes another star for its dual, so he's implying a binary here. Our sun is in a binary, and revolves round it in about 24,000 years of our Earth. A celestial phenomenon which causes the backward movement of the equinoctial points round the zodiac. So he's talking about this. The backward movement I will explain in a minute. But I just want to share that with you because this is a wonderful book, The Holy Science. Now, this is a book by Walter Cruttenden, which I've recently read a couple of times over, actually, just to go over the data, because there's quite a bit of data. It's not too complicated, but it's worth reading. This guy is the head of the Binary Research Institute in California, and he's got a whole bunch of scientists working with him. In this book, I believe he's proven without a doubt that we are in a binary star system. And the binary is the other star that's in with our sun is a star called Sirius, 8.5 light years away, and it's the brightest star in the sky. So I'll be referring to this great year as precession, the Platonic year, or the great year. But the thing is, most of this science is going to be based around this year. It's the most important thing astronomically to understand. Now, most of the monuments around the world, if not all of the monuments, the megalithic monuments placed all around the Earth, are monitoring precession. They are there to monitor precession. Now, let's explain how this works. So, a little bit of simple, basic science, okay? That's the orbit of our Earth around the Sun, and it's anti-clockwise. We also rotate every 24 hours, which we've just discussed, and that also is anti-clockwise. So every day we rotate anti-clockwise, and every year, every 365.25 days, we also orbit the Sun. So this anti-clockwise movement causes the Sun to come from up in the east and set in the west. Now, if you follow the stars that are also in that general area running from east to west, that, especially due east and due west, you'll find that those stars are also moving about the same speed as the sun does, and that's 15 degrees every hour. Now, it's always east-west, so if you're a star watcher you'll know this, but a lot of people believe me, are not aware of the fact the stars are moving. Really, I've spoken to very, very smart people, a lot of smart people, artists and musicians and whatnot. When I start telling them about the fact that if you watch the stars and they move and they go, what? The stars move? You know, it's sad, but it's true. It's true. They don't realise this. So both of these anti-clockwise motions, the rotation and the orbit, cause those zodiacal stars to come up from the east and go and set west. So that river, that celestial river, is always east-west. It's never west-east. Well, with the cycle of precession, those very same stars go backward. That's what Sri mentioned in his book, but that's a scientific fact. We know that it's a fact. We don't have to base that on just the one book. This is something that has been monitored for thousands and thousands of years because it gives us some perspective into where we are, as to where we are in this cycle. Now, so that's pretty clear to understand, isn't it? Yeah. This gives us our 24-hour day. That's the first fundamental motion of the solar system. This is 365 and a quarter days. That gives us the year. Now the great year works like this. It's a little bit more complicated to explain, but
just quickly, the stars are fixed, aren't they?
They're all moving. Everything's moving, right? But they are the fixed stars. Yeah, they are fixed. Yeah. The ones that are not fixed is what you call. Well, no, not necessarily. No, not those. The planets.
Oh, okay. Yeah.
So if you look out tonight, you'll see Jupiter out here. It's beautiful, blue. It's awesome. And over here you see Venus. They're moving, or they're really moving because they're moving against the backdrop. The backdrop is what you call fixed. But relative to themselves, they're moving. But relative to us, they're fixed. Okay? That's what we call fixed. Now, this is how the binary works. I've got two colours here for Sirius, but I'm going to start with red. Right? Now, I'll explain why I've got the two colours. This is how the orbits are described in The Lost Star of Myth and Time by Walter Crittenden. Something like this. Excuse me for my really poor. I'm not a good diagram drawer or writer for that matter. I detest my writing, so you have to put up with it. Now, this is the binary system. What happens is now here's a hint too as to why the stars go backwards. This orbit of our sun with Sirius is clockwise. Okay, there's the hint. It's a clockwise orbit which causes the stars to go west to east slowly every 24,000 years. And this has been noticed for thousands of years since the dawn of time. That those stars that go once around every day east-west, once around every year east-west, every 24,000 years go the other way. It took a lot to try and explain this. For thousands of years, really, there weren't many people who knew why, and we still only have two models to explain this, and this is one, the binary. Okay, this is the best model. The other one is the wobble. I'll explain that briefly. If that's the Earth, we have a 23.5 degree tilt in the axis. What they say is that there's actually a kind of a